So what are edge functions? I think most developers have used them in some context, or at least know what they are at like a high level. And in this video, we're going to go into depth of what an edge function actually is and look at the infrastructure that the internet needs in order to actually make this feature possible. And just to kind of spoil the video in a sense, let's look at what really is a edge function. And it is essentially just a block of code that gets executed close to the user making the request. So let's say I'm a user in Amsterdam, and I want to make a request to a server, not a hard drive, a server in New York. Now, this, let's say, has actually two servers. So it has a WordPress server, or a WordPress site that's hosted on a server, and it also has a NextJS site hosted on a different server. And based on what route the user requests, so if they request for like, I don't know, /form, maybe when we want to send them to like a custom, more flexible Next.js component or Next.js site. And if they go to a landing page, we want to send them to WordPress because that has better like SEO, let's say. Then we wouldn't want that request to travel all the way, by the way, this is in, let's say, New York, so it's far away. We wouldn't want that request to travel all the way to New York and then process that logic of which server, because that is more latency. And we're going to get into that, exactly why this trip has such a high latency. So what we want actually is just a small little function that is not on a server. It just kind of spawns in a very small container, and it's super quick. It just spawns in for some logic and then it goes away again. And when the user makes a request to our kind of like over our big server in New York, we quickly want to intercept that with an edge function. And we're going to show how this is possible later. But this edge function intercepts the request. It performs a little check, a little block of code. Which route is the user looking for? Oh, they're looking for the form? Okay, forward them to the Next.js server. And like this piece of code is executed incredibly quickly. Because it lives close. It's close to Amsterdam. It's close to where the user is making the request. And if they request something else, then send them to the WordPress website. And so here we have a much more efficient routing logic than the other way around, which would be if the user makes a request to the server says, okay, you need to request the WordPress site, and then I come back to the WordPress site. So that's 1, 2, 3 requests instead of just one that happens very quickly. Well, actually here the edge function would probably return here, and then I would return to the WordPress site, but because it lives closer, the latency is much lower. So that's the idea of the edge function. It's a small block of code that executes close to the user, and it can contain usually just some basic logic to speed things up. But kind of the interesting part of the video is in this diagram that I got AI to make. And this shows actually how complicated or how much infrastructure is required to make the internet work. So when you're in your home using Wi-Fi or just on the streets using your 4G and you use the internet, you're going to temporarily send signals through the air. And if you're in your house, those signals travel to your router. And that's why it needs to be close, because as you know, with Bluetooth and things that travel through the air, they can't go very far before like noise intercepts them and the signal doesn't make any more sense. So you need to be close. You need to be in the close distance. And everything else after that point happens through physical mediums. So when the signal reaches from my computer to the Wi-Fi through the air, it actually uses copper cables to pass that signal on to an internet service point. And so in this case, Amsterdam has one. It's a massive, basically just building in Amsterdam, and Ziggo has their routers there. They have like a bunch of routers, and other internet service providers pay Ziggo to have their routers in that big building as well. And that's because they can communicate very quickly if they're close to each other. So from your Wi-Fi router to the Ziggo internet service provider, there's just there's like massive cable infrastructure under the ground that's passing these signals to that building. Then that building needs to pass those signals to like a coastal station, because they're going to need to travel under the ocean to get to a US server, let's say New York. So it uses another protocol that passes those signals onto some coastal station, which you can see it as like a smaller version of this. And then that one turns those signals into actual light signals. And that's what makes this connection so fast. Because it's across the Atlantic, it needs to be super quick. And so it transfers those signals into like light, basically, and then passes them under the ocean, and then the reverse happens here. It goes from a data center, so like the opposite of this, and passes it on to basically the server where your website is hosting. So in this case, it's like if you're requesting for a website in the States. And this whole trip takes about half a second to a second. So obviously, if every single request for a website had a minimum latency of like between half a second and 1 second, the user experience of the internet wouldn't be as it is today. Because as you know, when you request for a website, it's basically instant. Because this is only the physical limit of the time. Then you still have to take into account that, you know, maybe you're requesting for a video, so that's going to take a lot longer to transfer than just a text, for example. So this is not like a reliable situation. And because of that, we started to invent something called a CDN. So if we go to here, we can have this CDN section. And an example of a CDN is, maybe they even have their logo, Cloudflare, yes. Cloudflare. This is an example of a CDN. And what they do is they go all around the world, right? So we have States. Let's make this a bit bigger. We have, let's say in our example, Europe. And we take a server, let's say a server which has just like a landing page. And instead of doing this whole trip, because this is in the States, let's say, they just take it and they duplicate it and they put it in Europe. And now the CDN's responsibility is it has a user, right? User requests for website. Cloudflare processes the request, sees that the user is in Europe, and makes a request to the European server. We've just skipped everything here. The only thing we do now is my house goes to Wi-Fi, Wi-Fi goes to exchange point, find the server in Europe, and return. And this latency is much faster. So that's the whole point of it. And now you can see this kind of makes sense, right? We just copy this. But this is mainly for like static things. So if you have a landing page, you know, you have images, you have text, you have that kind of stuff. But what if you have login? What if you have dynamic content that relies on a database, right? So now we have a database, and we can't just duplicate that, because if we duplicate that, then how do we synchronize them, right? So if here someone in Europe makes a change to the database, and someone in the States makes a change to like the same thing, then how do we synchronize that? It's possible, and with 2 instances of a database, it's not that difficult. But if you start adding more of these, then you're going to spend all of your compute, or basically all of the power you have, keeping these in sync. Because you're going to have users all across the world interacting with these databases, causing them to update and communicate with each other. So that's not really feasible. And for most applications, we keep one central database, and we duplicate others possibly for like reads. So let's say, or let's just keep it simple. We have this one, it's in the States, it will be the master. And we'll have this one in Europe, which is like, let's say, a reader. And anyone in Europe can read from this database because that doesn't require synchronizing. So those can be sped up. But if you want to write to this database, you have to forward that request on to the master, because otherwise, yeah, you're going to have the synchronization problem. And so this is where edge functions can come in, because let's say you're a company like Booking.com and you want to show two different pages to a user based on whether they're logged in or not. And you also want to track whether they went to a specific page, right? So you have to do a read. You have to see, is the user logged in? And you have to do a write, because you have to write to the database that the user visited this page. Then what you can do, just temporarily move this down, is use the edge function. So we take the edge function, and because it runs super quickly, because it's in this case, let's say the user's in Europe, it lives close to Europe. And what this function is going to do is it's going to verify, let's say, the tokens. And these are like, JWT tokens to make sure the user is authenticated. So this lives in the edge function. It can verify the tokens and see that the user is actually logged in. And it can immediately respond with the page that Booking.com wants the user to see if they're logged in. And then it can forward the request to the database. So if I just bring this down, it can just forward this request to the database, telling it to update the fact that the user visited this page. But this can happen just in the background. The user's already looking at the website and they can already interact. And now a company like Booking.com, it wouldn't be unrealistic that they're having like millions of people visit their site every single day. And if you remove a half a second of interaction time for 1 million users per day, that's worth a lot. That's just like instant content. And so for them, it makes sense to just check this as quick as possible, and everything that needs to happen in the background, forward it, let it happen in the background. And it can also just see, is the token fails, the user's not logged in, then show them the other page that we want to see. So that's this kind of advantage of the edge function, and it is only possible with CDNs because they have the capital to have this infrastructure where they have servers all around the world handling requests, very complicated, or actually they're not that complicated, but complicated algorithms for routing to which server they should go to, and then also just spinning up these edge functions, because a server is kind of like a bulky, it's a computer that's running and processing things, and it takes a long time to spin up, whereas these edge functions are like super quick blocks of code that just get like spun up by a server, handle the request, and then dispatch the result. So there's some innovation in there as well because of how fast they spin up and just disappear. So yeah, I kind of hope this video is interesting from like a hardware and infrastructure point of view, actually looking at how the internet works and why we need an edge function in the first place, how CDNs came to be about, and then how they were first like serving static content, but then the internet became more dynamic and more based on your session. So then we had the problem of synchronizing databases, and then we look at how edge functions can kind of reduce the load of or the latency of having multiple databases or dynamic content. So yeah, hope you guys enjoyed this one, and hopefully I helped build some mental models.